Hi students, my name is Nitesh and Shet. I am from Annavara. So last class we discussed about the topic from 10th standard, that is refraction of light. In refraction of light we already discussed about what is meant by refraction of light and what is meant by refractive index. Also we discussed about spherical lenses, types of spherical lenses and ray behavior in spherical lenses. In last class we discussed about image formation in convex lens. So here we have to take the image formation in concave lenses. So let us take the image formation in concave lens. Image formation in concave lenses. So likewise, in the image formation in convex lens, here also we have to write the object placed, image formed, and size of the image, and nature of the image. Yes. So here we have to write all these conditions here. So firstly, here in this case, in image formation concave lenses, here we are considering only two cases. So firstly it is at infinity, another in front of the concave lens. So those two cases only we have to consider here. So let us take the first case, that is at infinity. So firstly, so at infinity. Yes. So before going to the ray behavior or image formation, so we have to write some of the parameters, that is 2f1, here f1, here it is f2, and here it is 2f2. So that means here this distance is equal to this distance and this distance is equal to this distance. So likewise we have to draw. So then the image formation we can get easily. Yes. So firstly it is at infinity means, so I told you the example that sun. So all the rays from the sun looking like parallel to us or parallel to the principal axis, like that in this case. So here we have to consider two ray behaviors. Those two are parallel to the principal axis only. So let us take those two ray behaviors. So here I will take one ray, it is passes parallel to the principal axis. Here also I will consider another ray, it is parallel to the principal axis. So here in case of concave lens, after refraction it diverges from the principal axis but appears to be meet on the principal focus here. So likewise we have to take, so here just observe, here we have to take like this. So here it diverges, the original ray diverges from the principal axis, but here it appears to meet on the focus, like this. Then, so here also we have to take the same behavior like this, that is, so this ray, the ray after refraction diverges from the principal axis and appears to be meet on the principal focus. So here, like this, after that we have to extend backward. Yes, so like this. Yes, thus this is the ray behavior, or this is the image formation when an object is at infinity here. So where the image is formed here? So image is formed at f1. That is at f1 the image is formed. Then what is the size of the image? It is point size or highly diminished compared to the object. So object is at infinity, so the object is very high, or the size is larger. So size is larger here compared to the image. So image is highly diminished. it is highly diminished image is formed. Then, so what is the nature of the image? The nature of the image is virtual. So virtual and erect. Compared to the other natures or other image formation in concave mirror, so here we have to take it as a erect image. It is above the principal axis. The image is formed above the principal axis. So let us take the nature of the image as virtual and erect. Virtual and erect. Virtual and erect images formed here. So this is about the object when we place an object at infinity. So let us take the second image formation in concave lenses. To consider an object between 2f1 and f1. Whatever you can take anywhere, but here I will take any case that is between 2f1 and f1. Here I will take the object between 2f1 and f1. So here I will take an object here. Yes. So similar condition, here one ray is parallel to the principal axis, another ray it passes through the optic center. So those two cases we have to consider. Yes. So here firstly I will take the ray parallel to the principal axis and it diverges from the principal axis after refraction, so and appears to be meet on the principal focus. Appears to be meet on the principal focus. And another ray which passes through the optic center. So here it is, the ray passes through optic center here. Yes. So that means here just observe both the two rays are meet here. So here the image is formed. So that means image is formed between f1 and O. Between f1 and O. Between f1 and O image is formed. So here you have to write the arrow mark. Otherwise we can't consider it as a ray. So it's just a line. Yes. So here between f1 and O the image is formed. What is the size of the image? It is diminished. Diminished. Then what is the nature of the image? Just observe, we extended backward the ray. So we extended backward, and so that means it's a virtual image. It's a virtual image and it is erect. So it is above the principal axis. So that's why we have to take it's a virtual and erect image is formed here. So we have two cases here. So it is enough for your syllabus. So here we have only two cases in concave lenses. So you have to draw those two cases. So maybe one case or maybe two cases. So it based on the question. So let us take those two cases in only one view. That is already we know about the image formation in convex lenses. We inserted all the cases in that one tabular column. So here also we have to consider those two cases in one tabular column. So let us take that one. Let us take all the two cases in one tabular column here. So you know about all the cases. You can write that one. So here we have to take two cases 1 and 2. So firstly the first case, in the first case the object is placed at infinity, and second case we located the object between 2f1 and f1, that is between 2f1 and f1. So here image, where the image is formed there, so at f1 it is image is formed here, at f1 it is image is formed here. Then in case of between 2f1 and f1, so we have the image formed at between f1 and O. So that is between f1 and O. we have. So what is the size of the image in case it is highly diminished? And here in this case diminished. And both the nature of the image we get, it is virtual and erect. If I can write both as virtual and erect. Here also virtual and erect images. Yes. So these are the two cases of image formation in concave lenses. So we have image formation in convex lens and we have image formation in concave lenses. So it is very important for the examination point of view. So in question paper we get some of the cases here. So there you have to write the diagram, you have to draw the diagram, and you have to write all the cases, that is where the image is placed and where the object is placed, where the image is formed, and what is the size of the image is compared to the size of the object, and what is the nature of the image we have to write. So you have the 5 marks for that each image formation in convex lenses and concave lenses. We have all the 8 cases. So in each cases better you have to learn all the cases, because when we have in the examination, so those cases are having 5 marks for the examination. So we can easily get 5 marks in the examination. So I hope you understood those things and also enjoyed this part here. So those who are watching this video for the first time, please subscribe our channel and don't forget to press the bell icon. You can get the notification very easily. Also hit the like button. So thank you one and all. Be safe and stay home. Thank you.